Okay, good evening everybody. So Madhavi,
Can we do today hash map and casting and multidimensional arrays?
good point. Hash map, no, that's part of collections. And casting, I'll talk about it in the next class, I think. We'll talk about it in the next class. And
Okay.
what is the other one?
Multidimensional array.
Multidimensional arrays. It's I don't need to spend. Okay. It's how do I say that? It's kind of an arrays, but it's a two-dimensional array, three-dimensional array. So it's kind of let me think about it. Okay, because let me look at my schedule also, and because I need to put these more important concepts actually, because I'm going deeper on that, but I want to go little breadth-wise. I need to cover these concepts. So first, let me cover in my way, and then we'll talk about it. Okay. More important topics in using my experience, interview perspective or code perspective, every single. So multidimensional arrays, it's you already know. It's just one level up to the arrays. I think once we talk about arrays, I'm expecting that all of you can try reading it. It's pretty simple. And definitely casting, we will talk about it, because that's a really decent topic, and especially I'll talk about that once inheritance is complete. And then hash map, that is part of collections framework. It's way down the line. I'm not going to talk about it. So okay, any other questions, Madhavi or anybody else? Okay, let's get started then. So these are the topics that I wanted to cover today. Let's talk about method overloading. So method overloading. So we talked about methods, right? So we talked about methods. Method will have method name, and it will have the set of arguments, and then of course it will have the return type. Okay, and then it will have the method body. So this is the method body here. So in some cases it makes sense to use the same method name within the class. Okay, so one of the examples that typically every book or every Java trainer takes is, let's say there is an area calculator. Okay, so let's say there is a class called area calculator. Okay, and here there is a method called area. So, and then you will pass the parameters, right? So you may be talking about area of rectangle, you may be talking about area of square, or you may be talking about area of triangle, right? So in this case, it is if this is h and this is b, half bh is the formula for calculating the triangle. And if you provide one side, so if one side is a times a, or a square is the area of square. And then area of triangle, you need two sides. So a and b, and then a times b is A times B is the area of rectangle. So you don't need to mention that area of rectangle, area of triangle, area of square. Okay, so based on the number of arguments can tell you sometimes that you are talking about the area of a particular shape, right? So if I give you area and then if I give you double side, okay, this side here, right? So if I pass you just one here, then I'm talking about area of square. So if I give you two, then I'm talking about area of rectangle. If I give you three, I'm talking about something else. So I can use the same method name to calculate the area of different shapes. But the method name can be same. So if you think in any context, if you think that, you know what, even though I have used this method name, I think it makes sense to use the same method name one more time in the same class. Java does allow you to do that. You can have two different methods with the same name. Then you may be wondering, hey, how does JVM identify that? How can JVM bind? What exactly are you talking about? Which area are you talking about? Are you talking about the area of the square? Are you talking about the area of rectangle here? How does JVM identify it? Okay, so JVM identifies this way. There is something called method signature. There is something called method signature. So what this method signature is, your method name and your parameters in that particular order. Let's say your method name is M1, and let's say you are taking three parameters, right? String, int, let's say long. You're taking three parameters. So your method name and the arguments it is taking in that particular order is called method signature. As long as the method signature is different, your JVM is fine. What I mean by that is, your method name can be same, your arguments have to be different, meaning your string int long can be your long int string, or M1 string, M1 int, M1 long, M1 int comma string, M1 long comma int. M1, we have covered long int string. Now I can do int long string. You see that? So these are all different methods. Even though their method name is same, they have a method signature. See here, if you talk about it, you have the same types, long, int, and string. But here, the order is also important. The method signature is your method name and the arguments and their types in that particular order. So here you are taking the first parameter is string, second parameter is int, the third parameter is long. Here the first parameter is long, the second parameter is int, the third parameter is string. So they both have two different signatures. These two have different signatures. This is the third different signature, fourth, fifth, sixth, seventh, eighth. So you have 8 different methods with the same name, even though you have the same name. So how JVM identifies is that, how JVM identifies, let's say that M1, let's say Venkat. if I call like this, if I call a method M1 with the parameter Venkat, then it determines, hey, so M1, there are a lot of methods with the name M1. Okay, but what are you passing? You are passing string. Okay, so which method takes only one string? Which is this one here. So it will identify that, okay, this one M1 of string is what I have to call it. JVM can dynamically identify that. It can bind based on what your parameters are. It can bind to the appropriate method. That's why it's called dynamic binding. Okay? So it can identify the appropriate method and then invoke that. If you call the same method with M1, 12 Venkat, then it will say that, okay, this is of the type int, 12 is of the type int, and this is of the type string. So which method here is taking int and string as the parameters? Okay, this one. So this is what I would be calling. So JVM would call this particular method. So JVM does not get confused even though you have the same method name. It allows it as long as your method signature is different. Your method signature has to be different. And now you may be wondering, hey, what about my return type? So your return type can be long here and your return type can be string here. Let me write down here in a different paper. So let's say M1 string. This one returns, let's say, int. M1 string. How about this one? You may be wondering. But your return type is not considered as part of your method signature. So as far as your compiler is concerned, your Java compiler treats that this method and this method have the same method signature because it ignores the return type when it thinks about the method signature. So your return type is not considered in method signature. So your M1 string and M1 string. So these are even though they are two different methods, they have the same method signature. And your compiler itself, your Java compiler itself will throw an error saying that, I'm sorry, boss, you can't have the methods with the same method signature. Did you understand? This is called method overloading. Method overloading means having the same method name but with different signatures. Method signature is nothing but your method name and your parameters that you expect in that particular order. All the number of parameters and the order of the parameters of the type. That is called method signature. As long as the method signature is different, compiler allows you to use them as the same method name. So method overloading. When I say overloading, every time from here onwards, it's a technical term. It's a software engineering term. From here onwards, we'll use it. The other day I told you that plus is overloaded operator. If you do 2 plus 3, JVM will understand that you are talking about 2 plus 3. You have to do mathematical addition. But when you do hello plus world, JVM will understand that, oh, 2 strings in between, so JVM will concatenate them like this. JVM will concatenate like this. So it is doing 2 different things based on the context. That is called overloading, meaning it is doing more than one thing. In your design discussions, in your team meetings, people talk about it. Hey, why not overload that? Okay, so that is called method overloading. It's one of the most important interview questions. Later I'll talk about something called method overriding. So one of the most frequently asked interview question is, what is the difference between method overloading versus method overriding? So we didn't talk about overriding, but this is method overloading. Any questions? I'll take questions. Anybody? Okay, so I'm assuming you all understood that. So let's talk about the constructors now. It was a simple concept. So now,
Venkat, I have a question. Actually, I was trying to talk on mute.
absolutely. Go ahead.
So why would they want to overload a method with the same name? I mean, for readability, won't it be confusing to see?
Right.
Or
In some cases, it actually makes sense to for the same readability reasons as you said actually. If it is so obvious, I'm talking about the area of a rectangle and area of a square. Definitely, it's again we have two camps here on this one. I'll tell you we have two camps. So there is a one camp here. Oops, not this one. So you have two options here, right? One option is area of square. Okay, and then you accept double A, right? Or the other one is area of rectangle, right? This is one way to do it. But the other way to do it is area double A. It is so obvious here. Okay. In this particular case, if I take the area of square and area of rectangle, just by looking at it, it makes a lot of sense. Okay.
okay.
And later we will talk about few. I will show you when I talk about. I will show you some classes that are given by the actual JDK Java itself. Okay, as part of the Java development kit, Java folks have given us a lot of objects for us to play with. Okay, and I will show you some classes there why overloading makes sense.
Okay.
Okay, I will tell you. One of the examples is I'll talk for one more minute. One of the examples is there is a let's say you are constructing a basket. Okay, let's say later we'll talk about the collection interfaces, but let's say you are designing an object called basket. Okay, basket is nothing but a bag. Okay, so you can add various items to the basket, meaning you can add laptop to a basket, you can add a string to a basket, you can add int to a basket, you can add anything to basket, and later you can ask the basket, you can pass the basket to other guys, and you can ask the basket, hey, give me all the items inside the basket. Is that a fair way to say that? Now, in this basket, you may want to add a string here. Okay, add string, and you may want to add an int here. You may want to add a long here. Okay, you may want to see here, if I don't use this overloading concept, I have to say explicitly add string, add int, add long. This is ugly. Add boolean, that is ugly. Trust me.
Okay.
When we talk about JUnit, I'll show you there are some assertions. So you have to take the same method name, you have to take a double as an input, you have to take a boolean as an input, you have to take an object as an input, you have to take a int as an input with the same method name. And trust me, that is 100 times more readable than add string, add int, add long, add double, add boolean. That is ugly. Trust me. Make sense?
Oh, yes. Thanks, Venkat.
No problem. Okay. So let's talk about constructors. Okay, let me recap in an object. So in object we have the fields, the instance variables, meaning the state, and we have the behavior. And state is called fields or instance variables, right? And we talked that all the instance variables get automatically initialized when you instantiate it. When you do car C equal to new car here, okay? Let's say you have your car here, okay? So let's say string VIN number, string make, string model, okay? We have 3 instance variables, VIN, make, model. Now I can create a car here, and then you say that C dot VIN equal to whatever the VIN number, C dot make equal to BMW, C dot model equal to X3. We can do all that fun stuff, right? So let's step back here and understand this. When you say new car, all these instance variables are getting initialized. So by default, all the strings get initialized to null because string is an object, and all the objects get initialized to null at the time of instantiation. But I don't want now. I don't want now. Well, you can change it after you create the instance. After you create the instance, now you can change the instance variables. You can add the appropriate VIN, add the appropriate make, and add the appropriate model. But my point is, I do not want the default initialization that your compiler gives. You want to, at the time of instantiation, you want to initialize your instance variables. Let me repeat it. At the time of instantiation, you want to initialize your variables, meaning you want to provide some values at the time of the creation of the object itself. In fact, let me ask this relatively fair question. Car C equal to new car. Here, C object is already created, right? Can you ever create a car without having a VIN number? If I don't provide it, if I don't write this line of code, this line of code, this line of code, what does it say? If you say C dot start, does that make any sense at all? Does this line of code make any sense? What car do you want me to start? Does it have a make? Does it have a model? Does it have a VIN? Does any car exist without having a VIN number? Does any car exist without having a make? Does any car exist without having a model? No. Then what is the make of this particular C now? You tell me car C equal to new car. I just did it. What would be the make? Make would be null. What would be the model? Model will be null. What would be the VIN? VIN will be null. Okay. So you're asking me to start that particular car which does not have make or model or VIN? Does it make sense? It does not make sense at all. So you do not want to wait until after instantiation. You want to initialize these important fields. You want to initialize these important fields at the time of instantiation. When you do this one itself, you need to pass your VIN number. You need to be able to somehow initialize VIN number, initialize make, initialize model. You can definitely change them after you initialize it. By default, they get initialized to null, null, null. But I do not want it. I want the car to be created I want the car to be created with a VIN number, with a make, with a model. I do not want a car to be created without VIN, make, model. And later I'll come to the argument that once a car gets created, you never want to change your VIN or make or model. You can change your color, you can change your gear, you can start and stop, but you never want to change your VIN and make and model. I'll get to that later. But my point here is that you want to initialize these instance variables. When I say initialize, what I mean by that, providing an initial value. You can change it, definitely change it later. I need to be able to provide an initial value. So that's why I'm saying to initialize these instance variables. Is there a way? Yes. That is called your constructors. And in fact, when you say you're a new car, in fact, you are calling the constructor here. I'll get to that in few minutes. But let's define a constructor. Let me show you how to create a constructor. I'll take the same example. So, car, right? I'll take the same example. String, VIN, this is a VIN number. String, make, string model. And of course you have these methods like a start, okay? And you have methods like a stop. And probably you'll say, you'll provide a sysout, car starting, car stopping. These are methods, right? This is good. But now my point is, when I do a car demo here, okay, let's say when I say starting, I'll say starting, okay, starting, the make, and then model, right? And then I'll say stopping, okay, stopping, make and model. Now, in the car demo, let's take a look at it. Car, C equal to new car, okay? Now let's say C dot start. Now, let's run this guy. So starting null now. So your make and model and VIN, all these guys have been initialized to null. But my point is, this is when I'm creating the object, right? Every time I use a new operator, I'm creating an object. This is the object. This is actually object reference, meaning it's a remote control to the actual object that is created on heap. Now, my point is, at the time of instantiation itself, at the time of creating the new object itself, I want to initialize it. This is where I want to specify my make, model, and VIN number. How do I do that? Well, this is how. The constructors, now this is where I'll talk about the actual constructors. Constructor is exactly like your class name. Constructors are exactly like your methods. Constructors are exactly like your methods, but no return type with the two conditions. One is constructors will not have any return type, no return type. No return type. Number two, the constructor should have the same method name as your class name. Same name as your class name. You cannot have any name like your methods. If you can have a start, a stop, paint color, you can do change gear, you can do accelerate, you can do decelerate, you can have a lot of methods. And you can have, these are all method names, but in your constructor name is exactly same as your class name. So this is your constructor, and exactly like your method, meaning your parameters and everything, you can pass your parameters, and then you will have your constructor body, but it will not have any return type here. There is no void here. There is no return type here. Okay, you can definitely put it. Compiler does not compile it. So compiler does not complain about it, because compiler treats this like a method, not like a constructor. But no return type is the constructor. Now this is constructor. Constructor. Now constructors also take parameters like methods. So I'll say string VIN number, okay, string make of the car, okay, string model of the car, okay. Now are you getting it? I'm taking the VIN number, make of the car, model of the car. You pass me, now I will take these values and initialize these guys, meaning I will assign whatever the VIN number that you provided to me, I will assign to this instance variable. So I'll say VIN equal to VIN number, make equal to make of the car, model equal to model of the car. Now are you guys getting it? This is the constructor. This constructor is taking three different arguments: VIN number, make of the car, model of the car. So now the caller here, he will pass. So when would I, being the caller, when would I call this one? Well, like how you call new this one, this is actually the constructor. This is where you need to provide your values. So how many strings here? 3 strings. What is the first one? VIN number. Now when you say new car, this is where you're calling the constructor, and this is how you call the constructor. Constructor is used at the time of instantiation, and constructor is used to initialize your instance variables. They don't do much logic. You don't want to put logic in constructors. You want to use the constructors only to initialize your instance variables. Let me show you with an example here. New car. Now I'm taking, this is my VIN number, 1 2 3 4 5 6 is my VIN number, and I'm now providing my BMW is my make, and X3 is my model, right? Now take a look at it. Starting BMW X3. How is it? Well, you are calling the constructor that takes 3 strings. One is this one, this is the VIN number, okay, and make of the car, model of the car. So you called this one, right? Now when you called this one, what happened? I have taken these values, okay, I've taken these values and assigned to my instance variables. Now when you call the start, these are readily available for you. Make and model have been assigned. They are not null and null anymore, because I called my own constructor and I provided the initial values of these instance variables.
Does it should be in a sequential way there, Venkat? For example, VIN number, when you write it down in a main method there, you just gave it like VIN number.
Beautiful.
VIN number.
Beautiful
Yes,
question.
it should be in a
Yes, the first string here will be taken by this one. The second one will be taken as your make. Your third one will be taken as your model. Exactly in that sequence. That's exactly how it will be taken. If you crisscross this one, if you want to do it X3 and BMW, and now X3 will be your make and BMW will be your model. See, starting X3 BMW. So how many of you understood this concept? Is it really crazy? Constructors? And here you are calling the constructors. You always call the constructor to create the object. See here, you are creating the object and you are using the new and your constructor. This is how you create the object. Anybody has any questions? I'll stop here. Did any of you follow what I said, what I just said? How many of you understood that? It's okay, you can talk. That's fine. Let's be more interactive. Anup, did you get that?
Yes, Venkat. Maybe I need to do a few examples, but I got what you're saying.
Sure. Uma, did you get that?
Yes.
Is it above
I
your...
got it, but I...
Let's... we will do hundreds of constructors. No worries. Yeah, Madhavi, you have a question?
Yeah, there means constructor is the same name of the class, but there
Exactly.
is public, so we are not getting here public, so it's okay.
We do not talk about public yet. Okay? That's okay. Here, all I'm saying is the same class name, your constructor name, they should be exactly same. Including the case. Java is case sensitive. If you do, see here, see here it tells you return type for the method is missing because you may be wondering, hey, why is it treating like a method? My intention is to write the constructor. Yes, boss. If it's so, if your intention is to write the constructor, then you have to use the exact same name as your class name. If you do not, then your compiler thinks that your intention is to write like a method. Your intention is to write a method, not a constructor. It doesn't know that, right? Compiler doesn't know about it, right? So it is saying that, sorry boss, your method should have a return type. Well, if I use the exact same name as the class name, then it treats like constructor. Okay, constructors don't have return types, then I'll not complain about it. Let's say you only have a make and model. You do not have a VIN number at the time of the creation. At the time of the creation, somehow you do not have a VIN number. You only have a make and model. Well, what do you do in that case? You have two options. One is you can pass null here. If you don't have a VIN number, you can definitely pass null here. Right? That is definitely an option. Or the better option would be is actually to overload the constructor. Again, like how we just talked about method overloading, we have something called constructor overloading. What do you mean by constructor overloading? What I mean by that is I'm creating one more constructor here. This is the second constructor. But the second constructor will only take make and model. Make of the car, model of the car. I'm not taking a VIN number. See here, this is also a constructor because I've used the same name as my class name. So this is a constructor. Constructors do not have a return type like methods do. And next, here, this constructor has taken 3 arguments. These constructors have taken 2 arguments, and these are strings, 2 strings. You can have one more constructor that takes string and int. You can have one more constructor that takes string. You can have as many constructors as long as their constructor signature is different. When I say constructor signature, is exactly like a method signature, meaning your name and the arguments and the type of the arguments and the order of the arguments. So you have make of the car and model of the car, and you say now is make equal to make of the car, model equal to model of the car. Now you have 2 different constructors. The first constructor is used if you only have a make and model, and the second constructor will be used if you have all 3 at the time of creation of the object or at the time of the instantiation. Let's say I don't have the VIN number. See here, you provide only the make and model. Now your JVM, when you run it, it will call this particular constructor that takes 2 strings, because here you're talking about 2 strings here, right? So you're talking about 2 strings here. So this constructor will be called. Now take a look at it. What's it? Starting BMW X3, you're getting the same response. Of course, your VIN number will be null in this case. You can print it if you want. Starting, let's say, so in this case, your VIN number will be null. Starting your null, and then you can say if you have your constructor, then now you are calling this particular constructor now. Constructor that has 3 strings, 1 string, 2 string, 3 strings. So based on the number of parameters and time of the type of the parameters and the sequence of the parameters in the parenthesis, it will determine which constructor is getting called or which method it is getting called. That's it. Make sense? This is called constructor overloading. You can create as many constructors as possible. And I need to go ahead.
I have a question here. So when you say constructor overloading, it has the same what did you say? Anyway, when you say it's method overloading, you say start, and you have methods, 2 methods with the start.
Exactly. When I say method overloading, 2 methods or more than 1 method having the same name but having different method signature. You know what is a method signature, right? The method signature are the method name and the parameters that you're taking here, and the type of the parameters, and in that sequence. Meaning string you know, I'm saying, let's say string name int speed, let's say, okay, this is, let's say you have this start method. Let's say you can have one more start method, okay, string name, you can have string city. I don't know, lack of better. So here you are having 2 different start methods, one with the string and string, the other one with the string and int. This whole thing is considered method signature. Now let's say you have the same int something else, int okay, speed, the string name again. Okay, see here, even though you have the same string and int, but now you had them reversed, int and string now. So your compiler and JVM treats them as two different methods even though you have the same method name because the method signature is different. Agree? Similarly, your constructor overloading is nothing but having more than one constructors. Essentially, that's all, with obviously different constructor signature, meaning your parameters, your types, and the sequence of the parameters. Very clear?
Yeah.
Okay. Anybody? I don't mind spending more time. That's, if anybody has any questions. Ravi, you have a question?
So while you were explaining about the method,
Go ahead, Uma.
yeah, so you were explaining about the method overloading, like the start with two methods with start. So when we have the same sequence in the parameters,
Signature.
Or it will.
Your compiler will throw an error. See here? See here? So now your compiler will throw an error saying there's a duplicate method. Duplicate method start in car. Sorry boss, you have the exact same method, If I change this one to something like this, now these are two different methods because your method signature is different, meaning here start method with no arguments, here start method with string as an argument. Did you get that? But here, let's say your string city here, okay? Now it will break. Now you may be wondering, boss, here I'm accepting name, here I'm accepting city. It doesn't matter. It doesn't care about your method parameter names. It cares about the type of the parameters. So you have the start method with only one string, and you have the start method with only one string. I'm sorry, your compiler treats them as a single method, so you cannot have duplicate methods because these two have the same method signature. Now let's say I'll add one more int max, something like that. Oops, yeah, there is a. Now these are two different method signatures. Here start method with string, here start method with string and int. Did we get that point?
Yes.
Wonderful. Now I need to say one thing here. We wrote these many methods so far. Let's say do while demo. No. Let's say there is no let me take an example here. See, we have car here, car object here, current speed, started or not. We are saying speed up, apply brakes, start, stop methods. You have a print info method, print the information. And in the car demo, you have your public static void main. Now, you may be asking a question. Venkat, you are saying that your constructor will be called every time you call the new operator, meaning instantiation. Every single time you instantiate it, a constructor will be called, is what you're saying. That's exactly what I said, and I'll stick to it. But you will come back here and say that, where is the constructor here? If there is no constructor here in car class, how are you calling it? Well, there is a constructor that you can't see it. There is an invisible constructor that is provided by the compiler. So compiler provided a constructor here like this. Compiler, there is a public in between. I'm not talking about it, but there is a constructor that is provided by compiler automatically. You don't see it. You don't have to write it. Compiler is automatically giving it to you. But what kind of constructor? Because a constructor that can take 1 parameter, 2 parameters, 3 parameters, 1000 parameters, it can take any parameters, right? The one compiler gives you is a constructor that takes no arguments, like this, just empty parenthesis, empty. There are no arguments taken. So this particular constructor, this is called a default constructor. This is called the default constructor. A constructor that does not have any arguments is called a no arg constructor or a default constructor. Let me write them here. No arg constructor or default constructor. This is called no arg constructor, meaning no argument constructor. Or default constructor. Okay, and compiler is automatically providing you. You don't have to write this code. If you really look at the car demo here, new car, when you do it here, you are calling the default constructor. But you did not provide the default constructor. Well, you don't have to, because compiler is automatically providing you the default constructor. Getting it? See here, compiler is providing you code like this, car, without you having to do anything. That is free. Compiler is providing it for you. Car, no arg constructor, empty. That's it. It doesn't do anything there. It calls super. We don't worry about it right now, but it is providing. One second, let me finish my thought. So we have this default constructor here. Actually, by saying here new car, this is called instantiation. In instantiation, what we are doing is actually we are calling the constructor. If you look at it, we are calling the constructor. We are calling the constructor that does not take any arguments. Now go ahead.
Yes, sir. Then that means even if you don't have any constructor defined in particular class, but in your main method, if you just instantiate, right, you're telling that it will be called. In that particular scenario.
Who is speaking?
Ravi here.
Ravi, sorry, yeah. Ravi, look at here. Car 1 equal to new car of this one here. Look at it. This is the constructor.
Yeah.
This is the constructor that is not taking any arguments, and it is calling this default constructor or constructor that does not take any arguments, which is provided by default by compiler. Now you ask your question.
Yeah, my question is, when we, for example, last time when you, can you open the other constructor which you wrote before in the tar.java?
I'm getting there. So, go ahead.
Yes. There is, you gave like a couple of, you defined
two constructors.
Yes. Okay, then, but if I don't have one constructor in there, but I defined the VIN number and the make, the model, why can't, will it take the default constructor because we didn't define
don't jump yet. Okay. I'm going to come there in a very next minute. Okay. Probably after that it will be clear. Okay. But just hold your thought for just a couple of minutes. First, let me make sure everybody is on the same page. Everybody is on the same page.
Okay.
So far?
I have a question.
Yes.
If I have two methods, start, and one method is there, make model, and other is make model and VIN number. So
those are not methods, those are constructors.
No, there is overloading method.
Oh, okay. You have
one start, there is make model.
Okay.
And other is start, make model and VIN number.
Okay. Sounds good.
So we will make the two constructor for these two methods?
Methods are different from constructors. Madhavi. Okay, this is your method. This is your method. Method is a behavior of an object. You can call it any time. The constructor can only be called once in its lifetime, at the time of creation of the object. Unless you want to create one more object, once, see here, the object has been created here, see, using this constructor. That's it. And now for this C, to initialize, I'm repeating my words, to initialize these variables here, I'm using the constructor. Using the constructor, I'm creating the object. Once I have the object, I can call as many methods as possible, but I cannot call the constructor. You're using the constructor only, you got this object. If you want to create one more object, definitely you create one more object. Here again, you are using the constructor, one of the constructors, probably this one. Are you getting it? So constructors are used only to construct the objects. After that, so what you get as part of the instantiation is a real object, right? Once you get the real object, you can call the methods any number of times. But on this method, you cannot call the constructors anymore. Constructors are not available to call an object. Constructors are there to create an object. So once the object is created, your constructors will never be called on that object anymore. Are you getting my point? Constructor will only be called at the birth of an object. To create, to give birth to an object, the constructor will be called. And that's it. For this life of this object, your constructor will never be called. You can go ahead and create one more object. To create the object, again, you will use the constructors. But again, until that object is dead, your constructor will never be called again. But your methods, you can call them any number of times on that object. Is that point very clear? Is that clear, Madhavi, for you?
Yeah. One more thing. If I have C dot start and C dot start, right? Two methods.
Yep. Tell me.
So, and we will create 1, 2, 3, 4, 5, 6 VIN number, BMW and X3. And I want, I want to invoke the two methods. So, is it possible?
Absolutely.
For this constructor, can I invoke the two methods?
Okay, that's where my point is. For this constructor, can I invoke the two methods? That statement is wrong, Madhavi. Your constructor is used. This is your constructor. Your constructor job is done once an object is created. Now, once you got the object reference, you can call your methods like anything else. If you have 100 start methods, you can call any of them with your various method signatures. If you have them, you can call any of them. Let's say you have 2 start methods here. Okay? You can call both of them, and any number of times you can call it. Are you getting the point?
Yeah, I got it now.
Please don't get confused. The constructor here, this is the constructor. Constructor is used to create the object. That's it. And I'm saying the main purpose of the constructor is you will initialize these instance variables so that by the time the object is created itself, you will have some values. Definitely you can change the values. See, now car C equal to new car 1, 2, 3, 4, 5, 6 BMW X3, right? Now let's say C dot make. I'm changing the make from BMW to Honda. Okay? Now C dot start. This doesn't make sense. Look at it carefully. So here, as part of this constructor, I pass, this is my VIN number, this is my make, and this is my model, right? So at this point, my make is BMW, model is X3, but I changed the make here. By calling the field, I changed it now. So my constructor will never come into picture again once the object is created. Constructor will never ever be called. Constructor will only be called once at the time of creation of the object or the birth of the object. That's it. After that, your object is created, and after that you can call your instance variables, fields. They both are same, right? You can call your methods any number of times. C.start. Oops. You can call your C.start, and maybe you have 3 start methods, overloaded methods. You can call all of them. It doesn't matter really. Okay. And now you can change your make again. This time I'll say howdy. Okay. Now again call. Okay. Look at it. So to start with, you have, oh, I didn't start. So let me start the car right after the instantiation. And then once I change the make, see, right after the instantiation, the car make is BMW. After that, I changed the make to Honda. And then when I started it, the field here, the instance variable here is holding the value of Honda. Now I changed it to Audi. Now it is holding the value of Audi here. That is why when I started it, it says Audi X3. Did you all get the point? But the point is, I can change the make. That is not the point. The point is, at the time of creation of the object itself, I can give certain value to these instance variables. That is called initialization, providing the initial values at the time of creation of object. That is the reason why we use constructors. And you can have several different constructors, and they are called constructor overloading. And now, once this point is clear, now I wanted to go back one step here and say, I want to go back to old days. Let's say I don't have a constructor here. Okay. I just said that, Venkat just said that, if you don't provide constructors, or what I just said is, your compiler will provide the default constructor. You don't have to write the default constructor. What is the default constructor? This is how your default constructor looks like. No arg constructor. So car with no arguments. This is your default or no arg constructor, which is provided by the compiler. You don't have to do it. So I'm not doing it. Okay. Now I want to do it in my old fashioned way. I want to create an object. Car C equal to new car. For the last 5-6 classes, this is how we have been creating the objects. And why? My compiler is complaining. It's saying the constructor car is undefined. The constructor car is undefined. Why is it saying the default constructor? It is not finding the default constructor. See here, default constructor meaning a constructor with no arguments, just the parenthesis here, just the brackets here, just the empty brackets. There's nothing there. Right? It is saying I can't find the constructor with the empty brackets. It is saying it's undefined. Why does it say that? I just told you guys that your compiler will automatically provide you, that is free. You don't have to do anything about it. There is a small logic. If you do not provide your constructors, if you do not provide any constructors, if you don't have any constructors here, right, then your compiler will provide a default constructor. The moment you provide at least one constructor, the moment you start writing your own constructors, your Java compiler will not provide the constructor anymore. hey, if you don't write any constructors, I can provide you a default one, but you started writing, so you know better than me now, you are taking this is like a manual control. If you don't have any constructor, this is like an autopilot. By default it provides some functionality, some constructor. But once you start writing one constructor, okay, at least one constructor, then your Java compiler says that, boss, looks like you know what's going to happen here, so I will not provide a default constructor. That is why you can't do this anymore. Car C equal to new car, because there is no constructor here. Because compiler is not providing the default constructor anymore, because you took the control of it. You started writing your own constructors. If you want to do the old-fashioned way, meaning if you want to call the constructor that does not take any arguments, then you have to write that default constructor like this. Like this. As I told you, this will be provided to you by the compiler, provided you do not have any constructors. But you do have constructors, then compiler does not provide the default constructor. So if you want, you can create one more constructor. So how many constructors does this class have now? It has 3 constructors. A constructor that does not take any arguments, a constructor that takes string and string as an argument, a constructor that takes string, string, string as an argument. We have 3 constructors. And here now your default, when you say here default constructor, this is what gets called. You are not doing anything here, meaning your win will be blank, make will be blank, model will be blank. If you want, you can provide it. But if you decide that it does not make sense to create a car without having a win, make, model, then take out this constructor. Do not make, then you are forcing everyone to provide the win, make, model at the time of creating the object itself. Sorry boss, you can't create a car without providing a win, make and model. Then you take out this guy, and in fact you take out this constructor too. Then you're only leaving this constructor. Make sense? If you understand that point, it's pretty good.
I have a question here.
Yeah, definitely. We'll talk about it.
In the previous examples, in the previous classes, we used a string for in the dog class, for example.
Yes.
We use string name is equal to Johnny or something like that, right?
Yep.
We are doing the same thing here. But in a different way. Right?
Yes. Can one of you show me your? I want to change your classes. Can you zoom out your screen a little bit? You couldn't see the screen properly. Sorry.
No, it's hard to read, my friend.
It is hard to read, huh? Okay. I'll change it.
No, actually, on top we have zoom percentage. If we increase that, it's clear.
Okay. Yeah, Uma, or one of you, can you show me your dog class or some class that you are talking about? Uma or any of you who wants to share your classes? Because let us introduce the constructors there, and we can talk about it better. Who wants to do it?
I'm just checking whether
who has created a lot of classes? Anybody wants to?
Yes, I can share.
You can share. Who is? Sailaja?
Yes.
Okay. Yeah, go ahead. I'll show you how to improve these classes now with these constructors. Okay, go to your Okay, go to student and what is that student? Okay.
Yes, you can change here.
Oh, but you are already using the constructors. You are ahead, huh? Okay. Can I go back to the original ones like any dog class or?
Yes, I'll check it. I think it has those.
Okay. No.
Are here.
No, I don't want to take complicated examples and confuse everyone. Can you go to the person.java? You have
Yes.
already the constructors and everything. Okay, I'll not.
I think you can modify in this class also.
I have the exact dog example that you used in the class.
Okay, let's look at it. Who is it, Roma?
Yeah.
Okay, show me that. Okay, show me. Okay, okay. Can you go back to dog now? Yes, this is exactly what I wanted to. Can you give me the complete control?
Yeah.
Did you give that? Let me request. Let me request. I got it now or no, right? Yes, looks like I do. Do I? No, you don't now give me the control and you don't play with it. Let's see.
You have the control already? Okay, sorry. I was just wondering there too.
No, looks
You have
like
the control now, right?
no. I think I have to request or something.
Wait 1 second. Yeah, I got it. I'll just share.
Okay, now I have. Yep.
Okay.
Hey, look at it, everybody. This is dog class and then dog demo practice. Excellent, excellent. Now, let's look at dog.java. String name equal to Rax. Now, can you mute everybody? I'll just mute you guys. Okay. See here, this is a beautiful example. Thanks, Suma. Let's look at it. This dog has string name. So dog has field called name, age, color. So name is Rax. Initially we gave Rax and age is initialized to 0. Color is initialized to brown. So now what does it mean? Every single time a dog is created, the dog's name will be Rax, dog's age will be 0, dog's color will be brown. Every single time, I'm repeating the statement, every single time a dog is created, dog D1 equal to dog, dog D2 equal to dog. In that case, both the dog's names are Rax, both the dogs have the age 0, both the dogs have the color brown, both of them have the same thing. Because you initialize it like this. This is what you initialized in your class, your instance variables. But is that a fair statement? Is that a fair thing to do? Every single dog has a name of Rax, age 0, color brown. Can't you give me the control? When I create the dog, can't you give me the control? Hey, you choose your dog name, you choose your dog age, you choose your dog color. Isn't that fair? Now here, dog demo practice, here, when you say dog D1 equal to new dog, dog D2 equal to new dog, at this point, two dogs created with exact same name, whatever that name is, Rax, exact same age, exact same color brown. After that, she's changing it. But does it make sense? Why not provide the name, age, and color at the time of creation of the dog itself, at this point itself? Because what happens if somebody calls in between by the time you provide the name itself, if somebody calls it? Agree? So there should be a way. Is there a way, rather than me hard coding, rather than me deciding the name, I'm giving the default name for every single dog. The default name is Rex. So if you don't change it, that's your problem. But I'm creating a dog with the name Rex. I'm creating the dog with age 0. I'm creating the dog with brown color. You change your color later. Why are you penalizing me? But if I don't change it, if I forgot to change, if I forgot to name it, if I forgot to change the name, then you're creating a dog with Rex. Why? What's the deal with Rex and brown? I mean, in some cases, maybe it makes sense, right? So this is where the constructors come handy. So now I create the constructor. Now I'll say string dog name, okay, int dog age, okay, string dog color. Now at the time of creation of dog itself, you provide me what should be your dog name, what should be your age, what should be your dog color. So I will not provide Rex anymore. I don't need to, because I have a constructor now. I will use a constructor, and I will not give the color to brown. It's not my choice anymore. You create the dog with your own name, with your own age, with your own dog color. Are you getting it? Now, whatever the name, age, and color you provided, I will assign them. I will initialize my instance variables with the name, age, colors that you provided to me. Okay? So what I'm saying here is that whatever the dog name that you gave, I'm taking it and assigning it to name. I'm taking age and then assigning it to, I'm taking dog age and assigning it to my age. So meaning I'm initializing it. See, I'm not penalizing people now. Hey, it is up to you. When you create the dog, you give a dog name, you give a dog age, you give a dog color. See? Now, I can create two different. I can take out these two guys now. Now, I can create a Roxy, okay, with 5-year-old and with brown color. I can create one dog like this, and I can create a Johnny with 8-year-old with red color. See, I created two dogs now, and I don't have to provide the names anymore because I already provided here at the time of instantiation itself, at the time of creating the object itself. I don't need this one anymore. Oops. Now take a look at this one. Now you are not providing your default, you're not providing any default name, any default age, any of that in your class itself. Rather, you are expecting caller to provide them. Now see, name of the dog D1 is Roxy, the name of the dog D2 is Johnny. Roxy is eating banana, Johnny is drinking milk. Beautiful. Fantastic. This is the example that I've been looking for. Did you understand now? See, we are not putting any more Roxy, any more color here. No. I will not create a dog with some standard color, standard name. No. You provide. What do you want to name it? What do you want? What do you want your dog to be aged? And then color. Did you all get this one now? This is the importance of constructors. Now you go back and change every single class and you provide the constructors. Everybody got it? Can I safely assume that? Uma, did you get that?
Yes, I got it. Yeah.
Completely. No problem, right? Good. Now, that's about the constructors and constructor overloading. Now let's talk about, since we have a few more minutes, the next one is packages. Okay. So, packages. In your operating system, whether it is Windows or Mac, you have the folder structure, right? So I have a file, let's say venkat.txt. Okay. I may have that file. Can I have the same file name? Can I have two different files with the same file name? I cannot. But I can have the same file name in a different folder, right? Let's say I have two different folders. I have a folder called personal and I have a folder called work. If I have two different folders, here I can have venkat.doc and here I can have venkat.doc, right? If it makes sense to have the same file name, I cannot have the same file name under the same folder. I cannot have two different files with the same file name. Now let's talk about the Java classes also. So you are working on some module. Okay, there you have taken an example called car.java. Okay. Now, this is in OOP basics. Okay, here you are talking about OOP basics, how to create the objects, etc. Today, we talked about constructors, and I want to leave this car.java as is, and I want to create one more car.java. Can I create one more car.java? Because I want to take the same example because it makes sense. I want to create one more file called car.java. Can I create? I cannot in the same folder. So that is why we'll have to create multiple folders, right? So those folder structures, to avoid the name conflict, will create multiple folder structure. That is called packages. So you will create one package called OOP basic, and you create one more package. Package is nothing but a separate folder structure. Okay, you can create a separate folder structure called constructor. Okay, and now under constructor you can create car.java. Under OOP basic you can create car.java. Now, even though you have two different car.javas, you have two different contexts, right? This car is talking about OOP basic and this car is talking about constructor. Agree? So we create two different packages, and that is where we will put the same class name if we need to. And that is called packages. These are nothing but the folder structures. Okay? Let's say, but there is a standard in the company. Once you join any company as a Java developer, okay, there is a standard here. If your company name is, let's say, Google, okay, yeah, let's say Google. So their website is google.com, right? And then let's say you guys are working on a project for Google Plus. Okay, you guys are working on Google Plus. Google Plus is the project name. And then within that Google Plus, you are working on a module called circles. You know friend circles, right? So you are working on a module called circles, right? And then there is a one more module called family. Let's say there is one more module called family, and there is a one more module called photos. Let's say these are three different modules, right? So maybe you will create a customer.java here, customer.java here, customer.java here. Because photos customer may be entirely different from circle customer. Circle customer may be different than family customer, right? Right? So the convention to create the package is your company name, this is your domain name, right? Now what they do typically is your com, they reverse it. Com meaning your website dot com, right? Com dot your company name, Google, and then your project name, which is Google Plus, or you can simply say plus, and then your module name, module is circles, and under circles if you have a submodule name, let's say security, so you will create a folder structure like this. This is called a package. So what you will do essentially is just an example. I'm saying you will create a folder called com. Underneath that you will create a folder called Google. Underneath that you will create a folder called Google Plus. In Java, if you create a package like this, under the hood you will see a folder structure like this. You'll see a folder called com, underneath that you will see a folder called Google, underneath that you will see a folder called Google Plus, underneath that you will see a folder called circles, underneath that you will see a folder called security. Okay, this is how you create the packages. You go from broader to narrow. Com means everybody in the world. When you say Google, everything related to Google. When you say Google Plus, you are talking about a specific project inside Google. When you say circle, you're talking about a specific module inside Google Plus project, inside Google. And when you say security, you're talking about a specific submodule in circles of Google Plus. Okay? And now I'll show you what happens exactly. So let's say all these while core Java, right? Let's say we talked about the constructor here, right? Okay, I already created one. Let's say I want to talk about one more example. Sorry. Right click, new package here, right? So let's say I want to follow this convention. I want you to follow this convention from today onwards, and I want every single class to be created inside a package. I do not want any class to be created like this. By default, it says default package, meaning there is no package. All of them are dumped into one folder. If you look at it, so mine is pointed to my workspace is D Java training projects. Yours could be C Java training projects, and then Code Java Feb 2015 source. See, all of them are dumped here. Let's create some packages, and according to the conventions that I just mentioned. So right click, new package. Let's say com. Okay. Com dot, what is my company name? Sonic Vision, let's say, or Java Venkat, I can say, right? JavaVenkat.com. And then maybe I'll do training, I'll do projects, I'll do a lot of things. So within Java Venkat, I'm talking about training, right? So from broader to narrow, I need to narrow. Under the training, maybe I'll do Java training, I'll do .NET training, I'll do Scala training, I'll do Ruby training. So let's say Java. Now within that, now let's talk about Java, and then I'll talk about core Java, right? Okay. So within the Java, I'm talking about core Java, and within the core Java, now I'm talking about constructors now. Okay. Now, the moment I created this package, okay, do you want to see how it's created here? Com, Java Venkat, training, Java, core Java, constructor. See here? You did not do anything. Just by creating a package here, it created the complete folder structure like this. That is package. And now I will keep my car and car demo under this package here nicely. Agree? Now I can delete this guy. Right? Now let's talk about these ones. You know, I will do all the if-else demo, if-else demo, if-else demo, switch case, while let's say if-else demo, right? Let's keep them in its own package. Now tell me how to do. Com, from broader to narrow. Java Venkat. Java Venkat may have a lot of things he does. Training is one of them. Java training is one of them. Inside Java, he does a lot of things, and now core Java. And core Java is, what is that called? Flow control, right? I can say flow control. Flow control meaning this if-else. Right? So if-else, 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 if-else. Switch case comes under this one too, and I'm cutting it or refactor. I can do a move also. Okay, I'm moving them to which package here? This is the package, and now I can click OK. All the Java files have been moved here. This one, and addition demo, array demo, array demo, array demo, do while, for, do while and for and while demo. They go under loops, right? Let's create one more. I'll say com Java Venkat dot training dot Java dot core. Maybe I should have named that core, not the core Java, but that's fine. Loops, right? Fantastic. Now let's move do while, for demo and while demo. Right click, refactor, move to core Java loops. Fantastic, done. I want all of you to organize all of your examples like this. Meaning, you don't need to say Java Venkat because those are not my projects, right? You can say yours. So you say com dot, let's say your name, okay? Com dot Ravi dot training dot, maybe he does, he's taking SAP training too, let's say. So training dot Java dot core Java dot constructor. Okay, all the constructor related classes, he'll put it. Now, take a look at it. Now, I want to use the same car.java again in flow control. I can definitely do that. Now, see here, I'm selecting this package, right click, new, class, car. See here, we have two different cars here. Now, let's talk about one more thing here. When I create this car.java, if you look at the first line of code in any Java class, the first line of code specifies which package it is in. All this while, you didn't write it. All this while, there is no package here in the first line. Just throw public class, addition demo, public class, array demo, etc. The reason is there was no there is no package. They're all in default package. Default package means there is no package. Okay? But now we created a package. Look at this one. If you are inside, if your Java class is inside a specific package, you need to specify that package here as the first statement. This has to be the first statement. And also, let's say in my if-else demo, I'm using, let's say, I'm using hello world.java. Okay? or no, not hello world.java. Let's say I'm using a while demo. Okay, see here. You know what I'm doing here? I'm typing WHILE, or you can say W control space bar. It helps you with that while demo. While demo equal to new while demo. Okay. See, while demo is inside, is in a different package. Now I'm referencing, or I'm using a class from a different package. I am in what package? I am in flow control package. But I'm referencing while demo from a different package. See here, it's in a different package called Java Venkat training, Java core, Java loops. When you use a class from a different package, you need to do, after your package statement, you need to import that particular class. Import your fully qualified package name and your class name. That's called fully qualified class name. When I say fully qualified class name, your entire package name and your class name. Okay, your Eclipse is automatically doing it, but ideally you need to write it. Okay, if I remove this one here, see here, it is complaining, you're sorry boss. It will only look for what Java compiler is doing is, it is looking for a class called while demo in your package. You are in if else demo 4, right? This guy is in this particular package, so it is by default looking for the class in that package. Meaning, if you are referencing another class within the same package, you do not need to import it. But if you are using a class from a different package, then you do need to import. Make sense? And now, if you want to use it, actually you can click on this one and then say import. See here? And then your Eclipse is automatically, magically. We used to, when we were learning Java, back 15 years back, we used to write all of this in notepads, text pads. So now it's all fancy. It's automatically, you're getting it, right? But when I learned, at least that was not the case. So, make sense? So the package and import. That's it. I think that's it. That's it about the package. And the homework is go home and look at every single class that now, look at every single class you created so far and create the constructors. For them and use them. Okay, and understand them. Now, organize all of your classes into various packages based on their context. Based on the context, meaning if they are related to loops, then create a package called loops, com.shailaja.training.loops, whatever. Okay, so if they're related to control flow, then put them in flow control. Maybe this is not actually flow control, it's called control flow, I think. Yeah, it's called control flow, I believe. So I can change it. Oh, I can change the package, by the way. Right click, refactor, rename. I can change the package. Come on. Okay. You can do a preview and you can see how classes are changed. All the references will be changed automatically. Wherever those classes are referenced, everywhere it changes. Eclipse does a lot of magic there. It's a very, very powerful technique, refactoring. We'll talk about it later. Wonderful. Any questions at this point? Did you all get that? Did you all get the concept of packages?
Yeah, I have one question.
Sure, Madhavi.
If the folder is different and there is a file, can I import the file of the other folder or other package?
If you are using...
Folder, not package. Folder is different.
There is no such thing called folder in Java. It's all package. Package is underneath folder. Let's make that first thing clear. There is no such thing called folder. From here onwards, we are not talking folder. In your operating system, yes, the folder structure will be created like this. It will create a folder called com. Within that, it will create a folder called Java training. Within that, it will create a Java training, Java, code Java, constructor, etc. But we are not using the folder. This is the package. This whole thing is a package. If you're using, within this car.java, if you're using a class from a different package, let's say if-else demo here, if you're using that if-else demo here, right? See here, you must import it because that is not in this particular package. Your car is in this.
No, but you have.
Go ahead.
So, sorry, but you have, there is a core Java 1 and there is core Java Fab 2015, right? If
those are two different projects.
Okay.
These are two different projects. Don't get confused. Here, you cannot reference, at least so far, okay? You cannot reference a class from this one into here. So far, no. Let's say we never talked about it. We never talked about it.
Yeah.
So I'm saying no. If you have a class here in core Java, you cannot reference it here for now. We'll talk about it later. That's a different story. But let's talk, we are talking about classes within the same project. This is a Java project, right? See here, file, new Java project. This is how we created core Java. This is how we created core Java underscore Feb 2015. So within the project, I'm saying we will create multiple packages. Did you get the point?
Yes, I got it now.
Wonderful.
Thank you.
No problem. Anybody else? Any questions? Anybody? If you don't have anything, that's all I have for today. And
I got one question.
yes. Who is speaking?
It's not related to this class. It's my personal. It's Manikanta.
Yes, Manikanta. Yeah.
It's not related to the class. It's my own question.
If it's not related to, if it's nothing really related to class, then let's wait for a minute, Manikanta.
Yeah.
Let's wait for others to speak up, and then I'll stop the recording, and then we can talk.
Sure.
Okay. If you don't have any questions, I'm done. Thank you so much, everybody.
I just have one quick question here.
Sure.
Can you please make me the presenter?
Absolutely. You are the presenter now, Oma?
Yeah. Here on the left side, when you have different projects, I don't know what I did, but I have 3 things here. So core Java 2014 and SVN 325. So
forget about that SVN.
so
That's
only one thing, right? Only one thing you asked us to.
yes. You need to create only. Okay, go ahead.
You asked us to refer to one of those projects for reference.
Exactly. This one is the actual subversion. Okay. This is a whole subversion. Actually, you can remove it. Okay, that's fine. This is the whole. Actually, let's go to Java perspective for a second. Okay. This servers, you ignore it. This you objects, you created this one. Looks like. And For every small thing we do not create a project. I want all of you to understand that typically when you join a company, for let's say you work for a company for 6 months on a project, most likely you will work on 1 or 2 projects. The whole project is actually Java project here. Okay. I mean, I'm sure you will have more than one, but I'm saying each project is a big one. So what I recommend, this is what I recommend for all of you. Okay. I know your classes are all over. I want this to be removed. I want this to be removed. I want this to be removed. I want even this one to be removed because I don't know, Jan 2014, did you get it from me, or did you get it from, where did you get it from?
Everything is from you, but I don't know how I got it.
You got it from me. You can leave this one.
Yeah.
You can leave these two, okay? But you created these two, okay? Delete all of them. And what I want you to do is, I want you to create one Java project called core Java underscore your name. Core Java underscore Uma. Core Java underscore Sekhar. Core Java underscore Venkat Krishna. Core Java underscore Yuri. Like that. I want to see that. Just one project, and within that create various packages. So far you should only see one project. Of course, other than the projects that you got from Subversion. These are the projects. Look at on the right hand side, right? It is telling you that these are the projects that you got it from here. Java training venkat.googlecode.com. These are the Subversion projects. These are okay. You got them, meaning you checked out for your reference, Uma. But these are your local projects. You don't want these many projects here, okay? You create one project called core Java underscore Uma, and I want all of your classes, all of these classes to be properly, properly organize them into nice package structure. I want to see that.
Sure, yeah.
Make sense? You copy them, move them, you do all of that.
Sure, yeah.
Now, going forward for the end of this month, until end of this month, you will be playing in only one project. Of course, you can go back here and look at how I wrote here, all the other concepts. You know what I'm saying? Because these are mine.
Yeah.
Okay? And what I will do is I will create a project called core Java underscore Feb 2015, and then I will check in that. You can go check out that whatever the example that I'm talking about in whatever the example that I'm talking about here, all the examples I will put them in Subversion so that you can check them out. Agree?
Yeah.
Wonderful. That's all, everybody.
Thank you.
Have a good night, everybody. Take care.